This video contains lessons from my website, courses.objectzen.com, on RabbitMQ. In this particular video, we're going to look at how to implement store and forward queues in RabbitMQ. If you want to learn more about RabbitMQ, you can visit my complete course on my website, courses.objectzen.com. I hope that you find this video useful. In this series of lessons, we will be talking about how to create store and forward queues. The role of the store and forward queue is to be able to allow the publisher and the consumer to not be running at the same time, but yet allow them to exchange messages. Okay, so first you have the publisher, right, which will send messages to a well-defined queue. The one characteristic about the store and forward queue is that the publisher and the consumer does not need to be running at the same time. So once the publisher publishes a message to the queue, it can then disappear. At a later time, the consumer can come up and connect to the queue and dequeue those messages, right? And after it dequeues those messages will then get removed from the queue that is inside RabbitMQ. The reason why it's called a store and forward queue is basically that the messages will be stored in RabbitMQ until it can be forwarded to a consumer. So in these series of lessons, we will show you how to create store and forward queues in RabbitMQ. In this lesson, I'll show you how to create a message queue using the web management interface. So I'm here in the web management interface and on the overview tab. Now, in order for us to create a queue, we have to go to the Queues tab. And under that tab, we have a section called Add a New Queue. And this is the one that we're going to use to create our message queue. So if I expand it, you'll see that before we can create a queue, we have to fill in a couple of information. Now, the one that is required is going to be the name of the queue. So in our example, we will use test queue. Right? Another attribute that we care about is going to be durability. Durability defines if the queue will survive a message broker restart. A message queue can be durable or it can be transient. A durable message queue will survive a message broker restart, but a transient queue will not. So in our store and forward system, it is important that we have a durable queue because in this case, we want those messages to persist across a message broker restart. There's also other attributes that you can set for the queue, but in these series of lessons, we will not worry about those attributes. So go ahead and click on the Add Queue to create the queue. Once you create the queue, that queue name will show up on the top list of queues. And that is how you create queues using the web management interface. In the previous lesson, we just created a message queue called test queue. In this lesson, we will look at how to create a publisher to send messages to that test queue. In order to create a publisher, we have to use a client library. There are many different client libraries available for download from the RabbitMQ website, are available for different languages and frameworks. You have Java, Spring, Scala, Groovy, Ruby, Python, .NET, PHP, Perl, and many other different platforms. Okay, so in this lesson, we'll be using Java, right? And I'll be using Eclipse as my development environment. When you download the Java library, there's 3 jars that you need to include in your project in order for it to run properly. The main one is RabbitMQ client jar. And this jar depends on 2 other libraries, the Commons command line interface from Apache and the Commons IO library from Apache as well. So using these 3 jars in the workspace, I was able to get the sample working. Right. Here I have a sample program called Publisher Example 1. Right. In order to connect to Rabbit, you need to use a connection factory. Now, this connection factory, its responsibility is to create a connection to RabbitMQ, but in order for it to do that, you have to specify some information to the connection factory, such as the host name, right? What's the user and what's the password, right? So this is what I do in this section right here. And then once you specify that information, you then ask the factory to create a new connection. And in this case, when I call the new connection, it actually returns a connection object. And then once from the connection object, we can create a channel. Right? The way that RabbitMQ works is you can have multiple channels from one connection. So a connection is a physical TCP connection that is established with the RabbitMQ, and then you can have multiple channels associated with that connection. You can think of channels as more of a virtual connection, right, on top of a physical TCP connection, which is encapsulated by that connection object. In order for us to publish the messages to a queue, we use a command that is part of the channel called basic publish. When we use the basic publish command, we specify a couple of parameters. The first parameter is going to be the exchange that you want to publish to. And in this case, when we specify empty exchange, that is using the default exchange. We will go into what is the default exchange in a later lesson, right? And here, the second one is going to be your routing key. And this routing key is simply going to be the name of the queue that we just created. The third parameter is going to be your headers. Currently we don't have any. And the final parameter is going to be your message as bytes. So in this example, we are going to publish 10 messages to our test queue. So let's run it. Okay, so in my output, I see that I'm sending messages 1 to 10. Now, if we go to our web management interface and look at the queue that we just created, we can see that there are now 10 messages ready to be consumed. Since there are no consumers currently attached to this queue, there are 10 messages that are ready to be consumed. In this store and forward system, the messages will stay in the queue until it can be consumed. In the later lessons, we will show you how to create a consumer that will consume these 10 messages from this queue. So we just successfully published 10 messages to the message queue. It is always a good practice to close your channels and connections before you exit the program. So this is in this case, we close the channel first, and then we close the connection after. Okay, to summarize, to create a publisher, you have to create a connection factory. Once you create a connection factory, you have to set the information that is used to create that connection, such as the host name, username, and password. Once you set that information, you can create a connection. From that connection, you can create a channel. And using that channel, you can call basic publish to publish messages to a queue. Once you finish publishing, it's always good to close the channel and the connection. And that is how you create a simple publisher in RabbitMQ. In the previous lesson, we just published 10 messages to our test queue. While developing, sometimes it's helpful to look at what is in the queue to be able to inspect the messages that are currently on our queue. In this lesson, we will show you how to take a look at the messages using the web management interface. So I'm here at the web management interface in the queue section, and this is our test queue right here. And we have 10 messages that are already in the queue, ready to be consumed. To find out more information about the queue, you can click on the name of the queue. In this case, we have test queue. When you click on it, you're going to see the details of that message queue. We want to go down to the section called Get Messages. You have a couple options. The requeue, you can either say yes or no. And what that does is it will put the messages back on the queue after it has printed out what the messages look like. If you say no, this is just a way of draining the message from the queue. Right, and here you can see how many messages you wanna you want to query. And in this case, since I have 10 messages, I'm going to look at all of them. Right? So now if you click on the get messages, you can see that the payload contains our messages from the previous lesson. So in this case, hello world, this is message 1, message 2, message 3, all the way up to message 10. So you just learn how to use the management interface to take a look at the messages that are stored inside a message queue. Whenever you publish a message using the RabbitMQ library, you have to specify what is the exchange name and the routing key. And those are the first two parameters of the publish function. In this example, we did not specify an exchange, but instead we specify an empty exchange. When we specify an empty string for an exchange name, it is mapped to a default exchange. The way that RabbitMQ works is that whenever we created a queue, that queue is always binded to a default exchange using the queue name as the routing key. That is why in this example, we can use the default exchange and then the name of the queue to directly send messages to that queue. When you go to the Web Management interface, under the Exchanges tab, you will see a list of exchanges. The first one is going to be your default exchange. This default exchange has a type of direct, and it's a durable exchange. What direct means is that when you publish a message using a routing key, that routing key must exactly match what is the binding key for that queue that is binded to that exchange. Now, if you look at the queues, the test queue, and you look under the bindings, you will see that there's always a binding to the default exchange. The binding key is always going to be the name of the queue when binding to the default exchange. And this is why when we publish to the default exchange, we always specify the queue name as the routing key, right? So when the routing key matches the binding key, that is the only time when the messages will get forwarded to that message queue. So in this lesson, we learned that if you use the default exchange and you specify the routing key as the queue name, you can directly send messages to that message queue. And that is the reason why you want to use the default message queue, to be able to address a queue directly. In this lesson, we're going to learn how to create the consumer. Creating the consumer is the same as creating the publisher. First, we have to use the connection factory to create a connection by setting the parameters that it needs to create that connection, such as the host, username, and password. Once we have the connection, then we can create a channel. There are multiple ways to create a consumer. One style is to have a callback, such that every time you receive an event, your callback gets called. But in this case, we are using a queuing consumer, which is not event-based. In this queuing consumer, you can query for the next message, and it will block if there are no messages available. To create this queuing consumer, we basically attach it to a channel and then call the basic consume on that channel, pass it the queue name that you want to listen to, along with that consumer instance. Here we go into a infinite loop and just keep calling next delivery to get the next message from that queue. We pass it a timeout parameter of 5,000 milliseconds, which is equivalent to 5 seconds. And the reason why we do that is if there are no messages, then we simply break out of that loop. So this program will wake up, run, and then dequeue all the messages from that queue. And within 5 seconds, if there's no additional messages, then it will exit. Once it has a message, it will call this process message. If this process message returns true, then it will go and acknowledge this message by using the basic ACK. And after this acknowledgement, then the message will get deleted from the queue. If this process message returns false, it will not acknowledge the message, and that message will stay in the queue. And that's a very important distinction. If there are no messages within 5 seconds, it will simply close each channel and connection and then exit the program. And that's basically the workflow of a typical consumer. I already ran this program once, and you can see the output on the right. One thing to notice is that the redelivery is set to true, and that is because of the previous lesson when we dequeue the messages using the web admin console, right, and it requeued it. It actually marked the messages as redeliver. All right, so let's go ahead and for us to remove the messages from our queue. All right, I'm going to use the get messages, right, to drain out the queue. Okay, and you can see that now there's no more messages ready for consumption. Okay, I'm going to go back to my program, my publisher, and run my publisher to post 10 messages into the queue. Now if I go back to the web console, I can see that there are 10 messages ready to be consumed. And now if I run my consumer, you'll see that the redelivery flag is false because this is the first time that we are consuming the message. If I run this consumer again, right, you will see now that the delivery flag is set to true. So why are we getting the messages again? It's because in this process message we return false. Once we return false, we no longer acknowledge the message. So when this program exits, whatever has been received by this consumer is put back on the queue again because those messages were not acknowledged successfully. In order for the queues to, in order for RabbitMQ to remove the messages, each message must be acknowledged. And that's how we can guarantee its reliability. All right, so now if I set this to return true, and it will go into this condition to get the delivery tag and then acknowledge that delivery tag. So now if I run this consumer again, right, it dequeued it. If we check our web console, right, we can see that there's no longer any messages on the queue. Now if we run our program again for the consumer, we will not see any messages, and then simply the program will terminate. To recap what we have done, right, we have created a consumer by using the connection factory and setting the parameters that are needed to create that connection. We use a factory to create a connection, then we use that connection to create a channel. From there, we use a queuing consumer to listen on that channel and bind to this message queue. We have an infinite loop that dequeues all the messages from that message queue until there's no message left. For each message, we will process the message, and if the processed message was successful, then only then will we acknowledge that message. And after we acknowledge it, then the messages will be removed from the queue. Once we're finished processing the messages, we close the channel, we close the connection, and then the program will terminate. And this is the typical flow of a consumer program. So go ahead and download the example and try it yourself. In this lesson, we'll learn how to properly process a message and what happens when you process the message the wrong way and leading to losing messages. From the previous lesson, we know that we have to first get the message using the next delivery. Once we have a message, we can process that message. And then after we successfully process the message, then we can acknowledge that message to be deleted from the queue. And this is the right way to do it, right? Because if we are not able to process the message, we should not acknowledge the message. Well, let's take a look at what happens if we acknowledge the message before we process the message. So I'm going to run this. I'm going to run the publisher to put 10 messages on the queue. When we see the web management console, we're going to see that there are now 10 messages in the queue. If we go back to our program and we run the consumer program using the new flow, we will see that it basically does the same thing. Now let's try to produce a fault. So here, let's say that I exit the program or something, cause program to fault. So in this case, what's happening is I am intentionally calling system to exit to terminate the program, but before we process that message. Okay, so again, if we look at the queue, there's no messages on the queue. So we're going to run this publisher to post 10 messages to the queue. Right, and you can see there's 10 messages. Now if we run this consumer program. Let's see what happens to the queue. So what happens now, there's 9 messages because we already acknowledged one of them. Unfortunately, we didn't process that message that we acknowledged, and now that message is lost forever. So that's the wrong way to process a message. That is the wrong way to implement the consumer. Again, what you want to do in this case is to only acknowledge the message once it has been processed. And so if we run this program again, right, you will see that now, since before we had 9 messages, we will still have 9 messages. Right? And if we go back to the program and now if we run the program again, we'll see that now we can consume the other 9 messages. To recap, it's very important that you only acknowledge the message after you successfully process it. If you cannot process the message at that time, then you should not acknowledge the message. Right? So that's the main lesson for making sure that your system is reliable. So how do you deal with duplicated messages? First, we have to understand why duplicated messages happen. Right? So here I have the queue, the consumer, and the normal workflow. So in this case, the messages go from the queue to the consumer, and then the consumer will act the message. At that point, the queue will delete the message from the queue. Now, what happens when, say, the consumer receives the message, say message 1, right? But then the act does not happen, right? Say this didn't happen, but at the same time, that message already get processed and stored, or some operations already performed on that message. Right? So from the consumer perspective, it already processed the message, but from the queue, it still did not get the act, so it still remains in the queue. The next time the consumer receives a message, it may receive message 1 again. Right? In this case, it will be tagged as redelivered. Right? From the consumer, it sees that this message has been redelivered. and what is the consumer supposed to do. There are two strategies that you can take to deal with the problem of duplicated or redelivered messages. First strategy is to make the operations idempotent. What this means is even if you get the messages again, the operation will result in the same outcome. Second strategy is to tag the messages with a unique message ID such that the consumer can check to see if that message ID has already been processed. Right, so those are the two strategies I would recommend to dealing with the redelivered messages.